Good afternoon, good evening, good morning, wherever you are in the world. Welcome to my broadcast. My name is Diana Hooper, and I'm a theoretical physicist currently based at the ULB over in Belgium, where I'm doing my postdoc in cosmology. This means that I study the universe, the contents of the universe, how everything evolves, how everything interacts, basically everything happening inside the universe. It's a great topic, and I love coming on Happs and sharing my passion for the universe with everybody. I love talking science to everybody. Hey, Robert, nice to see you. Thank you for coming in for us today. Today we have a kind of different show, and I'm really, really happy to welcome to my show and welcome to the screen two very, very amazing women. So I'm bringing up Sophia and Kat. Hello, everyone. You're unmuted again now.
Hi, nice to see you all, guys.
Hi.
Okay, Sophia, you've been on my channel before, but maybe not everybody knows you. Do you want to introduce yourself?
Yeah, sure. So I'm Sophia, SophiaXCathrin. I'm still working on my PhD. I'm a PhD candidate at University of California in Irvine. I also do theory, cosmology, and astroparticle physics. And my main focus is working on dark matter and just trying to figure out how the universe kind of came to be and testing different models to see what works and essentially picking the universe apart.
Picking the universe apart to figure out what it's made of. Great thing to do. Thank you, Robert, for the Stay Safe Award. Thank you, Christian, for the Appreciate Award. And hello, Pablo. Hello, Catherine. Hello. Oh, I see you on screen. Just reading out the comments. Hello, Tana. Hi, everybody who's joining. Kat, do you want to introduce yourself?
Hey guys, it's so good to be here. I'm currently actually in Sydney, Australia, so it's 6:30 in the morning. So I'm trying to act really awake. I'm a deep space artist. I basically visualize the universe, but this is actually not where I started. My real job before I had this one was a video game developer, and I was also a mechanical engineer. And I've been running an art company for 5 years now, and doing some really cool projects, just like this one with Sophia, which I'm really excited about. So
it's quite a change from video programming and video engineer to now art. So do you want to tell us a bit about your art style and what got you into this type of art style? We can bring up any of the images if you want to show any.
Oh yeah, look, I started doing games because I'll be honest, I had a very rough time in the games industry, not for anything other than just extreme overwork. And I think I had that moment where I was like, I wasn't sure what I was doing with my life. I'm sure everyone has that at some point, and I wanted to connect people to the universe because it was something I just loved so much from a child. So I'll just bring up one of the images. This is some of the stuff that I paint. I do oil painting, by the way, but also digital artwork. This is an oil painting. And
putting this full screen for a moment so we can all see this.
I don't know about you, but like I think that looking at pictures of space, like how when you're stressed, you go and look at a sunset or whatever. I feel like doing that, but with space, is like that on steroids. It's like the most stunning, beautiful, relaxing experience. And it's just, I don't know, we get very tied up in the minutiae of life, and like we sort of forget that like in every direction and almost infinite distances there's galaxies and nebulae, and right now there's like black holes ripping apart stars, and there's just I feel like sometimes I like, if you've ever had a stressful day, just thinking about that just helps me put things into perspective. And I just want to share that with people because I'm unsurprisingly so into it. So.
I think you'll get no arguments from Sophia and me about how amazing the universe is. To me, it's also something that always just helps put life into perspective, knowing everything that's out there and the size of everything. The reason I have this channel is also to just share the universe with everybody and share what I've learned about the universe with everybody. And Sophia, you also do a lot of outreach, right? It's also always sharing this passion for science, for the cosmos.
Yeah, I just, there's so much mind-blowing things going on in the universe, and I really enjoy kind of blowing people's minds with all this stuff too, because there's so much out there that we don't understand and that we don't know. And the stuff that you can see is really cool, but the stuff that you can't see is also like
Yeah, and there's so much that we
incredibly
can't see.
awesome. Yes.
So just to clarify for anybody who came in late, the image that you
Bear
see
with
here
me.
on screen. Yeah, no worries.
I've just had a low battery alert. I've just got to plug my laptop in. I'm so sorry, guys. Be back
No
in 1
worries.
second.
I'll take you off camera until you're back. Okay, so just to clarify, for anybody who came in late, what you see here on screen is not a photo. It is a painting done by Kat. It's one of her digital paintings of the Eagle Nebula, the Pillars of Creation, as we're all accustomed to seeing. This is one of Kat's art pieces. So it's not. It looks like the standard photo we've seen, the amazing Pillars of Creation. This is actually Kat's oil painting, which is absolutely amazing, absolutely incredible. So, Sophia, you mentioned briefly what you do. Do you want to go a bit more into detail? Because usually people on this channel are used to me talking about science here. So do you want to just go a bit more into detail into what your research is about?
Yeah. So I guess one of the big things that I didn't mention is that I'm also looking into how supermassive black holes formed, because we actually don't understand that. We understand very well how stellar mass black holes, so black holes, several times the mass of the sun, formed. Like they form from huge giant stars collapsing and dying. Um, but supermassive black holes, you find ones that are a billion times the mass of the sun, as early as 700 million years after the Big Bang. And so stellar mass black holes couldn't have created those. They couldn't have accreted and merged enough in order to create like a 1 billion solar mass black hole by 700 million years after the Big Bang. And so one of the things that I'm doing at like right now is using a particular type of dark matter, and it's called self-interacting dark matter. So it's also cold dark matter, where cold dark matter actually just means like it's not technically like cold in the way of temperature, although like I guess it kind of just does translate to that. But what it really means is that very early in the universe, it had to be non-relativistic, meaning it had to move slow and not close to the speed of light in order to form the large scale, or in order to form the structures that we see today. Because if there was like warm dark matter, would actually diminish all the small scale structures that we see. And so the type of dark matter that I studied, because the standard one is called collisionless dark matter. So it's dark matter particles that don't see each other at all. They just pass right through each other in the same way that dark matter passes through you and me all the time. This type of dark matter interacts with other dark matter particles, and it actually has a consequence in dark matter halos that can cause the core to eventually collapse into a black hole. And so what I'm now doing is sort of tweaking models and testing different things. So like when typically people try to do this with like a constant cross section. What that means is like an interaction cross section is kind of like you can
Just
think of it as the
how frequently they bump into each other, right?
Yeah, so
Yeah.
like you could think about it exactly as the probability that two particles will interact. So like if you have a large interaction cross section, they're more likely, or the likelihood rather, that they would interact. They're more likely to interact. Whereas if you had a small one, they're less likely to interact. And when we look at different scales of galaxies, meaning like say small dwarf galaxies versus giant galaxy clusters, which are like 10, these are clusters of thousands of galaxies that are bound together in gravity that are also in a dark matter halo. The two kind of, they look different, so that the reason why self interactions were introduced in the first place is because dwarf scale halos, when you kind of simulate them with cold collisionless dark matter, you get really dense regions in the center, whereas observations tell us that they're not dense in the center at all. Like it looks like somehow maybe mass has been pushed out. And so that's why the self interactions were introduced in the first place by David Spergel, and I believe dying hard, just like in 2000, like in the around the year 2000. However, in order to solve like the dwarf scale problem, if I take that same cross section and use it on a galaxy cluster, it no longer looks like observations, because galaxy clusters are very happy with very dense cores and or very dense centers, and so implementing like a velocity dependent cross section, meaning that the likelihood of interactions changes with velocity. And and it's kind of cool because like you have like this sort of cosmic lab to test all this stuff that allows you to test different velocities, because velocity depends on mass. And so uh, particles that and stars, even like so any particles that are in like a dwarf system, because it's less massive, they'll also move slowly, versus stuff in a giant system like a galaxy cluster would move really fast. And the way that the velocity dependence would have to be is such that the higher speeds, so the higher the velocities, the less likely particles will interact. And so I'm trying to use that and a bunch of other different methods to see whether we can get a black hole in the center of one of these dark matter halos early enough in the universe.
Such an awesome topic. I never get tired of hearing about dark matter, and I never get tired about hearing you explain dark matter, Sophia, because you have a really nice way of explaining it.
Thank you.
So, Kat, we had a question from Christian in the comments that I think you already replied to in the comments, but I think it's a really nice question. So, Christian asked you, where do you get your inspiration from? Is it using Hubble images, your own telescope? What inspires you for these images?
So it's definitely a mix, and most of my artwork is actually, I work with like a commissioner. So I'll work with someone, like hypothetically, if you were to come to me, Dan, you say, I really like this particular galaxy cluster. Or if I'm working with Sophia and she's like, I love dark matter. And I'm like, oh God, I'm going to visualize that. So I use a mix, and people, it is amazing. The thing that I really love is and I think I'm not the one alone, is like just understanding your own self-efficacy about like how good you are at doing stuff and whether you can actually pull stuff off. And it turns out that everyone is far more confident of my abilities than I am sometimes. So I get asked to do really incredible stuff, like, visualizing dark matter, or, someone asked me to make a wormhole and all of these kind of things, but try and make it scientific. I don't know. So in a little bit, obviously, I go out and I get loads of research, European Space Agency data. I use NASA data, things from Hubble, sometimes radio telescopes like Spitzer and Chandler X-ray and that kind of stuff. But also, I am so excited. I have just started to take my own astrophotos. Like,
Nice.
My partner is a very keen astrophotographer. Yay! I'll give myself a little dance for that.
Yeah.
I know, right? So my partner does it,
That's
and like
gonna
all
be
my
incredible.
friends. It's cool. I like the idea of being able to like set up a scope and do like my own vision into the universe. I love that so much. And but every time I go out with my friends, because everyone is really advanced, I feel like such this, that like I stand out in a way that because I paint everything rather than shoot it. So, everyone sort of like is trying to help me and stuff. So I'm actually going out for the next 6 months to do like an intensive of astrophotography, but on my own. Or I'm actually with another lady called Sarah Logner, who runs We Are Stella, which is a female led and run group for women astronomers, and just encouraging them, because of course there are lots of unique challenges to women in the field, in particular having to go out in very remote dark locations by yourself, which poses some safety concerns to a lot of women. So it's just trying to pair people in a way that they can go out and shoot space. Anyway, as you can tell, I am like very excited because I've got my first telescope, guys.
Oh, that's amazing. I remember how excited I was when I went to. I just want to briefly interrupt and say thank you, Eleanor, for the Supporting Women Award, and thank you to the other people who gave awards. I didn't thank you before. I really need to do that. Thank you, everybody, for the awards. We really appreciate all of the awards you give.
Oh, that's so sweet. Thank you, Eleanor. That's so amazing. And so I'm going to be shooting a lot more. I've got one other side project, where I'm using actual data from the European Space Agency's Gaia mission as well. I'm building a chandelier. of the Milky Way galaxy, because we only normally see it side on, and I wanted to build it in 3D using 3D printing. So the little clusters are a little bit like a snowflake crossed with an atom and suspended from fiber optics. But that isn't the coolest part, guys. The coolest part is it's going to be 8 meters or 13 feet across in diameter, because, you know, I think there's only one thing better than space, and that's really big space pictures. So
yeah, I mean, if you're going to do this, you have to do it big. I was going to ask you about the chandelier at some point, so I'm glad you brought that up.
oh, awesome. Yeah. So basically, I get all sorts of different things. But you know what? The thing that really inspires me is being surrounded by amazing people like yourself, Diana, like, Sophia, like everyone on Twitter. Like, you can't help but be inspired by the universe when you are on social media. And I mean, as much as, there's a lot of terrible things going on, and it's a lot of doom scrolling, but it's always punctured by these amazing inspirational stories of people's research, like what people are fascinated. Like seeing other people's passion just lights me up. And I'm like, oh, I just want to go out and see the stars. And I found it very difficult while I was in the UK because it was just so bloody cloudy. Oh my God.
Always.
People in Europe. But, I think it's just an ongoing issue, not just the clouds. Like, thank God I'm back in Australia because there's no clouds here. But light pollution's so bad, guys. Gosh, like every time I went out, even when I was in the center of Sydney, and I looked up and I could see 9 stars. 9. I'm sure some of those were planets. They weren't even stars. The light pollution's so bad you can't even see the moon. It's just incredible. And I think that's something that's going to be facing everyone. So I that's why I like to look at, social media. It's a good way to remind people that there are stars and beautiful galaxies and swirling nebulae out there. It's not just light pollution and clouds.
Yeah, we can see
living
through
in
the
Los
pollution.
Angeles, I can totally relate to that. And I was raised in Toronto, which is also light pollution.
Yeah.
Oh.
Yeah, well,
I think I spoke over you. Yeah, go ahead.
I was just going to say I had an astronomy club during my university days. I was running an astronomy club, and we would often organise these kind of get-togethers where we'd go out with a couple of telescopes, bring along anybody who wanted to, and go camping. And we would usually drive to the most remote place we could find, still in Spain, close to Barcelona, so you always have sun city lights. But we were able to find some really remote spots, driving up a mountain, freezing, but staying up there all night with the telescope, and it was just such an incredible experience. You really see the difference when you get away from the city to actually see those skies. It's so amazing. It's so amazing.
I'm so sorry, but I just want to say, like, if anyone out there has not seen the Milky Way, because here's the thing, when you look at the sky, that strip you see in the photographs, you're meant to be able to see it with your eyes, guys. And if you can't, you live in light pollution. So please just even just once in your life, just drive out to somewhere remote. Sorry, Sophia. I was just very excited about that.
No, that's totally, no, it's true. Yeah, because that's actually one of the arms of the Milky Way. And then and sometimes I believe you could see the bulge, which is like the center, which is where the black hole sits. And I know that there's news out there that it might not be a black hole, it might be dark matter. I'm not sure. I haven't really looked at the paper yet, so we do have the EHT. The Event Horizon Telescope, and I think is going to be looking into that a lot more. So we'll see about that. But it resonated with me so much that what you said, Deanna, because I was also a part of an astronomy club in my undergrad, and in fact, when I entered undergrad, I didn't really know what I was going to do, but when I entered the astronomy club, I was like, this is it for me. And so and we used to do that too. Like we would go out. Eventually, I became president because I loved the club so much. And we would go out as well with telescopes and try to get out of the city. And it was really wonderful.
So we have a very nice comment from Christian here in the comments. So if anybody's here on Happs, you absolutely want to follow Christian. He has an amazing telescope. Honestly, I'm envious of his telescope, and does wildlife photography and videos. Absolutely incredible. Make sure you all follow Christian here on Happs, also space related. And Christian just made the comment that the southern Milky Way, or what you see in the southern hemisphere, is much nicer than what you actually get to see in the northern hemisphere. And I'm only limited to having seen it in the northern hemisphere, so at some point I have to travel to the southern hemisphere to verify that claim.
I am
Also,
very jealous as well. Yes.
I get all
I'm
the good
very
Milky Way,
jealous of her.
guys.
You get the good Milky Way down there.
Do you know what is surreal on a side note is actually coming to the southern hemisphere when you're used to looking at the northern hemisphere and then seeing a different sky and you don't recognize the stars and all of a sudden you feel a little lost. That is exciting and everyone should do that at least once. But also the Milky Way changes depending on, whether you're facing into the core or whether you're facing into the outer arms. So, in astronomy, we have like galaxy season, which is when you're facing away from the Milky Way. And you have obviously nebula/Milky Way season when you're facing into the Milky Way. So also, like, I think sometimes if you're looking to go out and observe it, and you want to see it and you are in a mildly light polluted, you're going to get a better chance if you're in actually Milky Way season, which I believe we're just coming into now. So now's the time, guys. I'm just saying.
Okay, so I think all of us could spend quite a while just geeking out about the universe and about space because it's clearly something we all really, really love. But we've heard a bit about both of your backgrounds, so now I want to ask the big question. Tell us about this collaboration. What are you doing together?
Oh, I am so excited by this. But I think that actually it's probably important to talk about some of the backstory and why this collaboration happened. I wondered if you were okay with sharing that, Sophia.
Yeah, if you don't mind, I'll just share a little. I don't want to put too much focus on that. Like I don't like people feeling sorry for me too much and all that. So like so essentially what happened is I had been going through a lot in my life, and so it hindered a lot of my work at the time, and I just regained confidence in myself and started to get right back into the groove, and I was ready to, make up for all the lost time with my research and all that. And then and I had this fellowship that allowed me to TA only half the amount that I would have that I would normally have to, and the other half was covered by the fellowship. And so I got this as soon as I just got, like, everything was great, and my research was going well. I'm like, yes, I can put more time into my work and get my papers out and all that stuff, because this is really important stuff that we want to get out there. I learned that my fellowship was cut, and so that meant that I would have to TA double. And for me, that was like, I mean, I don't want to be dramatic, but it was almost like death, because I really needed that time to, like, put into the research. And the moment that you get a double TA, like a double TA load, you're gonna get the worst classes. Like, I don't know if any of you out there are in grad school or have to TA. You might, like, know that it's kind of a luck of the draw, where
What does TA
you might
stand
get like
for?
a. Oh, I'm so sorry. Yeah, great, thank you. Teaching assistant. So this is a part of the
Okay.
way that we fund our that we fund our work. And so a lot of the assignments that you get are with professors that don't really consider that you're actually here to do research, and they don't care, and so they overload you in ways that are incredibly, like, outrageous. And
Mm.
so getting the double TA load, I was like, I'm you know
I mean,
I'm just
ultimately, it's
I'm
academic
out.
suicide.
Yeah,
It's like academic
yeah.
suicide when you have to catch up. And I saw a tweet from Sophia, and my heart actually sunk. And I remember sitting there, staring at the tweet, just like trying to imagine what it's like when it's like your life has built up to this point, and then all of a sudden it's like almost over. Because to be able to, because bear in mind, I just want to add how hard Sophia works, because I know you can't say this yourself, Sophia, but like every time I'm like, I wake up, she's like, damn, she's still awake. I'm halfway, I wake up in the middle of the night. I'm like, damn, she's still awake working. I go to bed, like she's still awake. I have no idea when Sophia ever sleeps, because like every time I try to talk to her, she's always working. And like, not just like little tiny bits of, just whatever, like really full on hardcore research work. And it always
And
just,
doing a lot of outreach as well. I don't know how you find time for everything, Sophia. It's impressive. You're doing so much hard work, and I had the same thought when I saw your post. Like, wow, you already have so much on your plate with the TAing, and now taking on double, which is absolutely not something you can really do.
it's,
Yeah, and
it
it
for
was
me.
just
Sorry.
yeah. So let me just say, yeah. So at that point, I was just like, I like, I'm not gonna have, time to, I'm not gonna have the time that I need to put into this project. Like, we need to get this, in academia, you kind of like need to turn papers. You really do.
Mm.
For many reasons, because, well, I mean, you're working on it, and everybody, you're not, it's a team, and so like people are kind of waiting for you, and I'm like, what am I supposed to do now? Like, I'm gonna have like classes with 300 students where I have to grade like 300 midterms twice, and then plus an exam, and grading every week, and teaching, and all that stuff. And so it's like, it was, I just broke. I will also say that there were a lot of people who found my donation page. Some people were like, told me to just do a crowdfund, and I just didn't feel right about doing that, because like, and I don't have anything. This is, if somebody felt they needed to do a crowdfund for the same reason, that's totally fine. It's just that for me, I feel like that's something that I would do, like, let's say if I needed surgery, right? And I didn't have the money or something. So people just kind of found my donate button on my blog site and started to donate. And so that was really, really kind of them. And then Catherine came to me with this. She's like, why don't we do a collaboration? And this is like, it's not like a crowdfund anymore. It's kind of like, I'm putting work in and giving you something. So it's kind of like
Yeah.
a replacement fellowship, if you will, and in the most incredible way possible, because I get to visualize this stuff that you've never seen before. So it's just, yeah, it was just, I'm touched in so many ways by Catherine. She's incredible. Thank you.
I
It's really
I
like
was
a
I was
fellowship.
It is a fellowship, and to be honest, I feel a little bad because actually Sophia's had to put so much work into this. Even though I've been doing the artwork, she's like, Kat, no, that does not spin like that. There's been so many different stages and iterations to the art, but basically, I saw the tweet and I was just like staring at. I must have stared at it for a really long time. And I was like, I can't just go past it. But I was like trying to figure out what is we can do. And ages ago, I reached out to Sophia about visualizing her work really long time ago. And that said, since, that sort of project had since settled down, because I've been like strangely traveling the world, a weird time to do it, but, with good reason for myself anyway. So I was just reached out and I was like, well, how about we just visualize this, in the most beautiful way and produce these beautiful artifacts that, people can purchase, and that, the funds will go to, basically fill the gap and hopefully more. I think that what we're making is really special. And I feel like this is the best scenario because everybody wins. It's like research wins, science wins, people get beautiful things for their home. I get to work on something really cool and work with someone who is really cool too. And then Sophia gets to do her
I do too, by
uninterrupted.
the way. I get to work with someone who's really cool. Sorry, I had to say that.
We're
I
a
had
good
to say that.
duo.
You really are. It's great to see you two lifting each other up, supporting each other. I like that the theme behind this project really is women supporting women. And that's something that, when I saw that, I was so happy that you two were doing this. Also, because I love Kat's work. I'm a huge fan of Sophia. So seeing you two collab was like, oh, wow, I really hope I can get them to come on my show and talk about this, because this is amazing. So it's really, really great to see this collaboration. Thank you for the Supporting Women Award. We very much appreciate all of your awards. So you've given a bit away of what this is. So maybe we can just give a bit more detail of what this collaboration entails. So what are we visualizing? What's happening here? What's the process in this collaboration?
I'll let you explain, Sophia, what we're visualizing.
Sure. Okay. So I guess the main piece is the research that I'm working on is dark matter halos. Essentially, the inner region is where you have like the self interactions going on, and the consequence eventually turns to causing the central region of the halo to collapse into a black hole. And so what we wanted to visualize was a dark matter halo, um, where kind of like a black hole has collapsed, and what I wanted to do, I added like kind of because like okay, so realistically, the biggest way that black holes will accrete mass meaning like eat mass and grow, is by accretion, but they merge a lot too. And with mergers, because people love mergers so much because of the gravitational waves, um, I had Cat throw in a black hole that's kind of like coming in, and so that we get kind of gravitational waves going on in there too. What you will see also is kind of like spirals around that black hole, because when when the collapse starts to happen, particles start moving really fast, and so we can't see dark matter, but we can try to visualize it in this way. And so you'll see that as well as gravitational waves, and just a really incredible piece. And so that's the main thing. But we're also doing like there's a sort of a galaxy in a dark matter halo. Another and a couple other pieces that are going to be based on on also like dark matter and black holes. I don't know that I can let Catherine take over on there, but it's all going to be based on the stuff that I do.
It's super cool, actually. So yeah, we're doing basically the formation of these dark matter halos, condensing into these black holes. And also, as Sophia said, we're going to be doing one with orbiting black holes because it makes pretty ripples in time space, which I love. Also, obviously, we've got the M81 galaxy surrounded by a cloud of dark matter, which is really beautiful. I mean, I'm biased.
I'm just drawing up my mental shopping list while you're saying this.
We're also doing what is effectively the cosmic web. So is it how's it called?
The cosmic web of dark matter.
Yeah, is it Laniakea?
Laniakea,
I'm sorry. Is it different?
This is kind of like no, that's actually like that's one kind of component. Like Laniakea is I think like a cluster of clusters of galaxies.
Right.
But the dark matter cosmic web is what you get when you zoom out, really zoom out, like and look at the universe at huge scales. Yeah.
So further back.
Kind of, yeah. Like so, if you could like take yourself and just like zoom out of the universe, there's in fact actually there are images from data already that kind of look like these two triangles, sort of like they're triangular, and you could see a cosmic web in that. So it's kind of like a network. It looks like neural networks if you've seen those. It shows you that like essentially it's dark matter that has created this sort of web and condensed into specific regions, and then has these filaments around it, and that's where the regular matter kind of fell into to create galaxies and stars and clusters and things like that we see today. Yeah.
So mind-blowing. So
I just pulled up the image from the SDSS of the two triangles, and every glowing dot you see in this image is a galaxy.
Yes.
Or a lot of galaxies all clustered together. It's wild, isn't it? It's crazy.
I also have like the illustrious image somewhere in there. That would be really cool too.
I can bring it up. I can bring it up. I was also just going to say.
By the way, illustrious is a simulation I use a lot in my work too. Not in this particular work, but I've used it in my work a lot. It's incredible. It's an incredible simulation.
It is.
So much work went into that.
So let me just bring that one up as well. So I'm going to just put it in full screen. So this is the illustrious simulation simulating where dark matter should be within the universe.
I think that's the Millennium simulation.
Right,
But
yes,
that's
sorry, this is
yes,
Millennium. I don't have the illustrious one loaded. Yes, this is
that's
Millennium.
totally cool.
And
Yeah,
this is
that's
the,
totally cool.
so this is what we expected it to look like. And if I bring up the other one that I had up before, and let me just find it again, got lots of things go on the screen now. If we bring up the other one,
It's
you
right
can see
down there.
that it's really, really similar. So our simulation
Wow.
and our observation are in very, very good agreement here.
Wait, this is an observation.
Yeah. The triangle one is the actual observation. The one that you can see, the orange and purple one, that's the simulation, the Millennium simulation. On the one at the bottom with the two triangles, it's triangles because the Milky Way blocks out what would be in the middle. So we're basically looking up the Milky
Right.
Way and down the Milky Way. So the Milky Way
Huge.
lines along the middle of the triangles. And yeah, these are real data points, real observations.
Isn't that insane?
It's
Oh
incredible.
my God.
And
Whoa.
but before I forget, I want to just make a comment there, Sophia. You mentioned that the cosmic web is like the neural network in the brain, and I love that you made that comment because on Wednesday we actually had a science broadcast collaboration here on Happs, where a lot of the science outreach people here on Happs got together and talked about cross-discipline collaboration. There was a neuroscientist involved, and one thing we discussed is how the neural net looks so much similar to the large-scale structure. And in fact, for anybody on
That's so
Happs,
cool.
let me just say that there is going to be part 2 of that conversation happening today. So a couple of the scientists are going to continue that collaboration conversation. I think it's starting in about 10-15 minutes. So there will be part 2 of that collaboration conversation going on Happs today as well.
Wow, that's incredible. So,
Yeah.
so we're doing that. We're also going to be doing some lensing type effects as far as I don't know actually if we were settled on doing lensing. I think it's lensing either around galaxy clusters or around black holes. So that's the very last artwork to be made. So it's still in progress.
Yeah.
Um,
I guess
but
we
right
still
now,
want to I guess decide on that, but maybe it would be I guess nice to just explain like what lensing is. Um,
sure.
Gravitational, yeah, gravitational lensing is actually an effect that proves the theory of general relativity, which says that mass bends space-time. So it's kind of like if you were to take like a bowling ball and put it on your bed, and you'd get this sort of like a kind of like a bowl, and that would be like a potential well. So that's what mass does in space-time. And so light travels in straight paths. That's like light just has directly straight paths, and it travels straight all the time. So with if you have, for example, a really massive galaxy cluster, and you have objects placed behind it in a sort of further back, like so it could these could be objects that would be like really far away. If mass didn't bend space-time, we shouldn't actually see them because they should be blocked. It's kind of like if you were to put like your I don't know, a chair behind a bush, you're not going to see it, right? So and that's what we would expect if mass didn't bend space-time. But because it does, and light travels on in straight lines, the objects behind it are emitting light that travels in straight lines along curved space-time, which creates these beautiful arcs. So if you've seen like these giant galaxy clusters with like sort of arced images around them, those are images of objects that are far behind that galaxy cluster.
So I've just put an image on the screen of actually one of the deep field views where you can see a lot of the lens galaxies. So every galaxy that you see here that looks a bit distorted, that's because of gravitational lensing.
That's just incredible.
Yeah.
So,
And
so basically, that
the significance of
oh,
sorry,
yeah, you
go
carry
ahead.
on. I was going to say that.
No, I just wanted to mention this. The significance of that is that gravitational lensing also tells us how much dark matter exists
Huh.
in that cluster.
That's actually fascinating. That's really cool. So basically, those are the images that we're going to be designing. Can we show people? Because we've never revealed them yet. So
I'm really happy if you want to reveal it on Happs. It will be amazing if you actually want to do the big reveal. So nobody yet, before we move into a reveal, we should mention when this comes out, how can people access it, how long will it be available for maybe?
So it comes out on the 10th of June. It is available for only 3 days. And then obviously the store is gone for good. So, and basically that's. Oh, thanks for posting the link. If you want to stick any email, your email and name, I can send you an email when the store it goes live. But yes, it's only available for 3 days, and I'm just very
And that's
excited
the
about
only
it.
way you can have access.
That's correct. So
You should also see the link up here on the screen as well.
I'm sure people will probably be asking like how much things are. We have like digital artworks, which are only $5. And then really massive prints at like I think 490, but then smaller ones up to 100. So it depends on your budget. There's something hopefully for everybody. And obviously shipping worldwide is $12. So yay!
I can't wait. I can't wait to get my hands on more space art.
And it's printed on a really, really, I mean, I don't know. I'm really excited by this, but I realize this is a very niche subject, but it is probably the nicest paper you have ever felt. I don't know. Sophia could probably attest to this. It is like it's compressed German etching paper from Hammermühle, made in Germany, and it is so nice. It is 100% cellulose paper. So it's designed to last a really, really long time. And we're using pure pigment inks. So the color is like, it's all there. It's so good.
So there are a lot of artists here on Happs, and I've already seen there's a few of the regular artists here in the comments. So I think everybody, the artists as well, will appreciate these comments and these details about the type of paper you're using and stuff like that. So I think it's definitely also comments that people here will appreciate.
Yay. Also, it's 320 GSM. Actually, you know what? I might be 410. I will just have to double check. It is between 320 and 410. I will have to double check that. But it is very dense and very like, it's got this nice, I don't know, it holds an insane amount of ink. So the black point, the gamma point is way darker than most papers. Which is why I like it for space stuff, because you can get those real darks. That's it.
It's very pretty, is what I will tell you, because I saw it, and it's gorgeous. It's very, it's gorgeous. Also, just I think maybe we should mention what June 10th we're talking about, because June 10th is different for everyone around the world.
Yes, which time zone? When does this open?
This is we're working in the PT, so Los Angeles time effectively. So, and I'll be, it's available internationally as well. We ship everywhere in the world. In fact, I actually believe that there's 3 printing printers, or one printer, but mainly based in London. But I do know that they've got a second facility now in Germany, and one which I don't know if it's online yet in the US, but the shipping is super quick. Like I was pleasantly surprised how quick everything turned up. So that's great.
If it's the same one as for the remastered series, that was really fast.
Yes, and actually it's the same paper as the remastered series.
Oh, okay. Yes, I'm really happy because I have some of Kat's art. I've been a fan of Kat for ages, and I got I actually got the remastered Pillars of Creation. I'm so happy with it. So knowing that it got here so fast as well, so I'm really happy to know that it will be the same one. I'm super hyped about your collaboration. So you have not revealed it yet. You've been very vague on Twitter, posting kind of blurry images. I wasn't sure if you were going to reveal it today, so I am super happy if we want to reveal one of the images. I really like that you saved this for Happs.
Oh,
thank you for the great broadcast award, Daniel.
Oh. Do we want to reveal the actual?
Yeah, let's start with the dark matter black hole. This is exciting. I feel like we need a drum roll.
I'm really happy here. Yeah, let's get a drum roll going.
So I'm getting my gloves on. Okay, I do cosplay. You should wear gloves when handling these, because
definitely. Are those your Sailor Moon gloves?
Sailor Pluto.
Sailor Pluto, yes, that's the one.
I've cosplayed Sailor Pluto and I've cosplayed Sailor Saturn.
Yes, love the sailors.
Yeah. Oh my gosh.
Okay, so
this is so exciting.
I'm going to put you full screen, Sophia.
Okay. Let me just unwrap.
So we're getting to see something that hasn't been publicly released yet.
Which one do we want to reveal first, Kat?
Whichever you want to do first, I don't mind. I'm just excited.
Oh, me too.
Well,
Me too.
The first one that comes up is the galaxy. Can you all see it?
We can indeed. Yes. Yes.
Is it okay?
So
Great. And so
this looks.
you can see, like, go ahead. No, you go ahead and explain it. You did this. So
So yeah, well, I mean, everyone, it's a common galaxy, M81. It's really popular in astro targets, but that blue you see around it is a dark matter halo, and it really is representing, the sort of formation of galaxies. And one of the reasons why, oh God, hopefully I don't get this wrong, Sophie, you can correct me. One of the reasons why we know dark matter exists is because, typically speaking, we would expect the center of galaxies to rotate a lot quicker than the outside, but we know that the opposite is somewhat true. So the only reason we could explain that is that there is a large amount of mass in these outer regions of the galaxies. And that's how we know that dark matter is actually there, because we can measure, the velocities using the laws of physics, the gravitational laws and so on. And our observations don't meet our expectations. So we know that there is something hiding. So I made sure that I painted it in this one.
That's
you
nice.
got that right. Yes.
That's awesome. I love it. I love it.
Give myself a gold star.
And I do want to mention something because this is something that's often mentioned a lot. Is that, like, this isn't the only way that we know dark matter exists. Because a lot of people will, and it's good to be working on different things. Try to explain this by modifying gravity. You can explain rotation. So these are called rotation curves when you plot velocities of stars in a galaxy from, like, the center moving outward. In the solar system, you do have that sort of thing where the speeds are lower, further away. Whereas here, in these galaxies, it's like they're relatively the same. They're moving too fast, and so you need dark matter to hold these together as well. And you can explain galaxy rotation curves with modifying gravity, but we also have evidence for dark matter in the cosmic microwave background that you can see in these sort of in the power spectrum. It's essentially kind of like you get these sort of like oscillations. So if you ever seen the sort of the plot that looks like a big hump, and then and then a smaller hump, and then a little kind of like bigger, and then it kind of goes just that way. Those are like oscillations, and the fact that you have one hump that's big and then the second hump that's smaller, and the third hump is kind of like, I think, relatively similar to that size, then the fourth hump is smaller, and then the fifth is larger, and so on and so forth, because you don't have them all decreasing. That tells you there's dark matter. If it was regular matter, they would just decrease, and they would just get, like, so you'd have the first hump being the highest, second hump being second, third being third, fourth, and so on and so forth, because this kind of like it's the oscillations that produce that. Another thing that you can't explain by modifying gravity is the fact that we have large scale structure, and in order to have large scale structure today, because dark matter doesn't interact with light very early in the universe, all kinds of matter which interacts with gravity would kind of go, like to sort of fall into these little dense pockets in space. And so, but everything was dense, so photons were bouncing off each other, and like kind of like when you look at the sun, don't look at the sun, but when you do, you can't see through it, right? Because everything's bouncing off of everything. And so that's kind of like, I like to use that analogy for that. And so when regular matter tried to go under gravity into these pockets, it got kicked out by light, by photon radiation, or excuse me, radiation pressure. So it just pushed it out. But dark matter was just happy to just chill and hang out, and light can do what it wants, doesn't interact with it. And because it was able to do that, and then once everything kind of roamed free, and photons roamed free as well, then regular matter kind of fell into these pockets and formed the galaxies and stars that we see today. But it's the fact that we got the large scale structure that tells us that you need the dark matter there, because the regular matter could have done things too, but we wouldn't have large scale structure if it was just from regular matter. So I just wanted to point that out. And
so I just want to say
you
there.
can also chime in, Deanna.
Yeah, I just want to say there that I love the direction you took with that conversation, because people who follow me regularly know I can't go a broadcast without showing the CMB. And I was wondering if today I would have a chance. And you cited on that, so I brought up the CMB image and the power spectrum, the one with the humps.
Yes.
And you gave me the perfect chance, and people always say that I can't go a broadcast without showing it. And even today we brought up the CMB, so thank you for that. For everybody giving awards, thank you very much. Somebody gave us the Mona Lisa Award, so thank you everybody for the awards, for the Super Clap Award, for the Broadcast of the Week Award. We really do appreciate all of the awards you're giving, and everybody in the comments. We do really appreciate all of you being here. Okay, so I'm really happy that you've revealed one of the art pieces. Oh, we're getting another one? I'm going to put you full screen again, Sophia.
Okay.
Oh my gosh.
Yeah, so this is our dark matter halo.
I love it.
And so hang on, let me look at it from so this guy is the wait, hang on, I need to kind of just see the orientation again.
Signatures at the bottom.
So sorry?
Oh,
sorry, Catherine?
sorry, you carry on. Oh, I thought you said orientation of the thing. I said the signature's usually at the bottom.
Oh yeah, right. But I'm trying to figure out which one of these again was from the dark matter halo and which one is coming out or coming into it. So I believe this one here is the one that came from that collapsed from the dark matter halo. So you kind of see these swirls and stuff around it because particles move really fast around the black holes, and this black hole is coming in to merge with this one, and so you have these kind of gravitational waves moving around over here, and then this huge dark matter halo.
So when I saw the other one, I thought, oh, I'll get the other one, and now I've seen this one, and now I want this one as well.
I love how, I must say that printing those colors of purple is incredibly hard to get right. And the amount of work that the printing team had to go into matching those is incredible. Like, it seems like you would just hit print, but no, they would have had to have made many, many, many versions of that just to get those colors spot on. So I'm really, really pleased, because those really vibrant purples are just hard. They show up incredibly vivid on, computer screens. So to try and get it even close on a print is amazing. And also, I think you can probably see how black that black is really next level. So yay. I love this.
It's gorgeous.
Can we bring up the image of, because we have an image of this dark matter halo and thing in the comments. I don't know how to bring this up.
Which one? Yeah, I think you clicked on it already, and I'll just put it full screen once it's up.
Amazing.
Absolutely amazing. I love this image.
So what you might not have been able to see from obviously seeing the webcam or the version of it is that you can see not just this, so you've got these spiral lines, but then you've also got what it looks like kind of ripples, and this is the ripples of the time space as these two black holes orbit each other, creating these violent shakes in the universe and sending out these beautiful ripples. So you can kind of get the edges of them. I don't want to make it too obvious, but you can sort of get the sense of those going on, as well as now, Sophia, the orange. And is that particular motion, or is that magnetism, or what aspect is that?
So let me because I'm unfortunately on my phone, and so what you all see, I see like a really shrunk version of it. So okay, looking at the orientation of this, I think which one of these? Yeah, so there might have to be some adjustments, but because the really bright colors are actually supposed to be the particles moving really fast that
Nice.
that collapsed into the black hole, whereas the other black hole moving in should only be producing gravitational waves.
Right, awesome. And I
Yeah, which is and that's yeah. But the light color, like the bright colors, are yes, are the particles that are moving really fast around
And
around the
I
black hole.
suspect once black holes come close to each other, they start to steal each other's matter or steal each other's particles. Is that right? And they'll sort of leech off one another in a way, or not at all?
That definitely happens with, like, say, a black hole orbiting a star. The black hole will suck off, or like suck up, like, the matter off of the star. But black holes can't eat mass out of other black holes, because remember, inside a black hole, you're gone. Like, there's no coming back.
Oh, I mean, just
Right?
things in the
So.
the accreting part.
Oh, and
Of
the
the
accretion disk, yeah, you would definitely, yeah, you'd have like, you'd have, yeah, you can have that, because with the accretion disk, the parts that are further out away, yeah, you would have sort of like a mix of them. Yeah.
There's been a lot of back and forth, as you can imagine, because I don't know anything about science. And it's been nice working with Sophia. So this is like, so she would send me I took a screenshot. She sent me little things like, it doesn't look so much like this. It's more like this. So I get these beautiful diagrams sent to me. But it really helps me because I'm a very visual person. So if you give me a book, I struggle. Like I am just a hyper visual person, and in a way, I kind of love that. We can visualize some of these things because I had to ask a lot of questions to Sophia, like would it, about how they would form. And she would have to spend a lot of time, actually thinking about like, well, what would it look like? Because this isn't something that people just go out and visualize normally.
Yeah. Right.
It's part of the problem with our
It's
jobs is
difficult.
that we can't actually see this.
Yeah.
One person that actually was I want to mention him, Ethan Siegel. If you don't follow him, starts with a bang. He's on, like, on Twitter, but if you're not on Twitter, his blog is on Forbes, and he always writes about, like, literally everything cosmology. Brilliant guy, and we spoke to get to, like, about this, and so I wanted to give a shout out to him for that.
Oh, awesome. And yeah, I guess the only thing I would just wanted to add is just obviously these are only going to be available for 3 days. So if it is something that if you would like, I like that you could have something in your home that is like a little piece of someone's research, or it's like and not just that, but it's like helping support the research. So it's like, for me, like I like to fill my house with like things that are really meaningful to me. And it's like every time I look at pictures of space, it reminds me that we're just on a little tiny rock floating through the universe. But also looking at something like this, reminding us that it's helping to go to create some really impactful and hopefully cool research, whatever comes out as a result of the research, just to be able to help that come to fruition, I think is really amazing.
So we had the comment before, which I think you already answered in writing, but are the prints unique, or will there be multiple versions of them? Like, is it only one person can get each print?
Oh, yeah. So there's unlimited amounts of prints for each design, but they're just available only for 3 days. So if so as long as you're there within the 3 days, you should be okay to get exactly what you like.
Awesome.
I've done stores previously with limited artwork, but that's just because they were limited prints. I didn't have any more, and it sold out within 5 minutes. And I had my friend so upset at me, and I felt terrible after it. So I tried to avoid doing those because there's just too much demand, and I can never calculate it properly. My friend said, "Oh yeah, I was on the motorway on the highway, and I saw that the store went live. So I was like, right, better pull over." So he took the first exit, pulled into a car park, looked at his phone, and everything was gone. And I was like, "I'm so sorry. I didn't want that to happen." So so we're just making this so it's a lot easier for people to get hold of too.
And just as a reminder, if anybody came in late and hasn't heard all of the broadcast, this is a collaboration work between artists and Scientists Art and Science meeting. The money from this collaboration is to help Sophia finish her PhD after an issue with her fellowship. So this goes to a good cause. This is a collaboration of women supporting women, and the artwork is absolutely incredible. And I'm so, so happy that we got to see it today, because I wasn't sure if we would reveal it, and I hadn't seen them yet, just the small thumbnails here when you uploaded them. I was so looking forward to seeing them, so happy with this. So we have been online for about an hour now, so we're going to start wrapping up. Is there anything else you think people should know about this collaboration? Anything that we might have forgotten?
I want to say something. I want to say something because somebody on, I think, Twitter asked if like you would get a detailed explanation or like a little of what, whatever image that you got, and that I think is a perk that would be pretty cool for like one of the big ones or whatever. And so so you get an explanation for the science behind each image too.
Thank you for the champion award.
Oh, it's a great conversation point for people to be like, what's that? And you're like, well, let me tell you about science. I love having, I think it's really cool because I think it's an opening conversation. And one of the things that I like to talk about often is how sometimes academia can be a bit scary, and especially, really advanced research, because ultimately humans, none of us want to, oh, you missed the art. We should maybe bring it up. I'll just pop it up there. No one wants to feel stupid. No one in the world, of course not. But so I think a lot of people shy away from science, and we have a big contingent of people that are quite anti-science. I truly believe it's because people are too afraid to put themselves out there and potentially look stupid, because you do have to go through a learning phase, and before you understand it, you have to not understand it. And that's quite confronting for a lot of people. And one of the beautiful things about art is that you don't necessarily need any prerequisite knowledge to get the picture. You can just kind of look at it and just appreciate it for some pretty swirliness. But it's even better once you get the research, once someone explains like, oh, actually, this is a dark matter halo. These are ripples, in gravitational waves. These are black holes. This is a black hole that was already existing, and this is one that it's effectively attracted, I suppose. And it's just, once you have all of that, it means so much more. And I kind of like that. And I don't know, I really believe in the power of images. My brother saw an image of a vase in a magazine a while back. I realize I'm going on. Hopefully this is okay to tell the story.
Sure, no problem. We can go on as long as you want.
Okay. So my brother saw a vase in a magazine. It was a computer mag, and it was a 3D one, and it was really beautifully rendered. It had all the caustics and light coming through it. And this is back in the day when we had magazines. Remember that? And he was like so fascinated by it. He was very, very young at the time. And he's like, I got to learn how to do it, and then he went out and learned how to do 3D graphics. Then he learned how to do he learned how to actually do the shading. Then he learned how to do, actually it wasn't enough. He needed to understand the coding and then how the graphics cards worked. Anyway, long story short, 20 years after seeing that picture of a vase that inspired him to learn about how it worked, he's now making virtual reality simulators for doctors, and is probably, and his company will save the lives of millions, if not billions of people. And it was all from a single picture that inspired him. And I think it's really important to have things that inspire us, but you never know who walks into your home or your office or anywhere. Might see something and go, what is that? And just that little spark of inspiration paired with some really cool information that, like the research that Sophia can bring, might actually set someone on a path to become, a scientist, or to become an engineer, or to become an astronomer, or just to come, just to go down that STEM path, or, any kind of path. It might just inspire them to really make a difference in the world. So you never know what the impact you have, but I think having pretty pictures definitely starts. And I think most people that are really into space had a moment like an image or a moment where they were like, oh gosh, this is really cool. Like it might have been watching Cosmos, or it might have been going out for me with binoculars and looking at the moon. But there's usually like a moment. I'm sure that you had one, Sophia, and I'm sure, Diana, you had one too. But there was something that sparked it. So my only hope is that some of these images can be that sparking point for someone who knows who it is. But fingers crossed.
That's amazing, and it's really nice to remember the power that images can have on people. Absolutely amazing. So let's just quickly remind everybody when they can get this and where they can get this.
So yeah, this is available from the 10th to the 13th of June. So literally in a couple of days. I've put a little link up that Matt. It's a short link. I'll make sure that it's on all social media. It's on all of my on my bios and everywhere. But if you put your email in there, I will send you the access codes. Oh, it's up on the top corner.
It's in the comments as well.
It's in the comments before. So yeah, just if you don't want to miss it, I know it's a really short turnaround for the stores. So if it's something that you don't want to miss out on, just pop your email in there, and I will send you an email and let you know when it's live. And yeah, I'm very excited.
Awesome. I'm really looking forward to this store. I can't wait to get my hands on more space art. Okay, so apart from this amazing collaboration that you two have put together, is there anything else you're working on you want to tell us about? Kat, you already told us about the chandelier, which is an awesome project. Is there anything else you want to tell us about or promote, or just like throw out here, now is the time to shamelessly self-promote, this is what this is for?
Look, obviously working on the chandelier, which is really cool, but I think that this is a really important moment in history. And I spoke to Sophia about potentially doing more collaborations like this, using art. And, I think a lot of people want to support scientists, but have no real medium for doing this. And, we've never spoken about this publicly, but I would love to do probably more of this kind of stuff and use the combination of amazing science communication, which Sophia does such a great job. She spends all this time building these great audiences and like helping train, teach people and share her love. Share that with some science research, some art, mix it up in a little bag, and hopefully we can create I don't know, maybe this is a more ongoing thing. I don't know, but I would love to work with Sophia again.
I'm super excited if that kind of happens.
Yeah. It's also kind of like a nice shift from them towards STEAM, where we add art in as well. And so I love it. It brings more people together. I feel like less. Because sometimes just science alone can make some people feel like maybe, I don't know if left out is the right word, but like they don't belong. And I actually want you all to know sometimes we feel like we don't belong too when we're here, and so it happens to us all. But I feel like also it's a very nice way to sort of merge the two and shift over from STEM to STEAM and just bring everyone together through art and science.
Yeah, I think that's a really nice. Yeah, I want to do more with Sophia. I want to do more with other scientists, and actually, maybe I kind of maybe even want to create some sort of movement where arts and scientists work together to visualize and create assets and artifacts that everybody can have. Because the one thing I have these little gripes about, whenever you go out to, so if you go out to most art galleries, what you won't see? You won't see pictures of the universe. You'll see a million pictures of bowls of fruits and abstracts and portraits, and they're all very well and good. Don't get me wrong. Not going to diss on them, although I personally find them a little boring, but whatever. But you don't go out and see beautiful, sparkling galaxies. You don't see these swirling nebulas. You don't see dark matter condensing into black holes. It's just the sort of stuff that you don't see. But for me, the whole point of having images in your house is to have something that really means something that inspires you, something that starts a conversation, something that you look at and it really lifts you up. And I I realize that there is a massive lack in the market of what we're doing. Like, and I actually believe that there are lots of people really interested in it. You only need to look at the followings that we all have, but also, you go to NASA on Instagram. It's one of the biggest channels on there. And tell me why it's so hard to just go out and find beautiful images of the galaxy or the cosmos. Why is that? It absolutely drives me mad.
Agreed.
So I really want to use this as a platform, not just to promote the science and get it into people's homes and into their hearts, but as a way to fund research. Like, this is a really valid way of doing it. And actually, it's a lot of fun. I got to admit.
I agree.
Any future collaborations you do, both of you are always welcome back on my show to discuss any ongoing projects, any future collaborations. Happs is about collaborating. It's about bringing people together from different communities. We've had a lot of people from many different backgrounds in the audience today. So anytime any of you two want to come back to Happs, you're always welcome on my channel. Okay, so any closing thoughts from you two before we wrap up the broadcast?
I just wanted to say thank you.
Thank you for having us. Yeah, there. Go
Snap.
No, go.
Oh, I'm so sorry. There's like a little time delay. So, but yeah, I just wanted to say thank you. I think it means a lot to me. Not just to you, Diana, to all the viewers, and also I want to say thank you to Sophia, because I feel like this would not be possible without you. Like, I'm just grateful that you were open to do this, and it's not often that I get to publicly praise Sophia, so I'm going to take this opportunity right now.
Please do so. Please do.
Sophia is an incredibly kind-hearted, warm, and amazing soul. She works so tirelessly to promote science, and I really feel like good things should come her way. And I am so glad that we can put this together. I am just so grateful. And I'll be honest, I sometimes feel a little, sometimes in my own head, and this is entirely my own construct, I sometimes feel intimidated because I don't feel like I know a great deal about the actual science. And you know what? Sophia is so kind and so patient, and she never makes me feel stupid, even though sometimes I make me feel stupid. You know how you do it. I don't want to cry. And I just am very grateful. Aren't we all? And I just want to say thanks, Sophia. I have loved every second of this campaign, and I know that we're only a few days away from launch, but even now the overwhelming support it's like actually giving me goosebumps. I'm punching the mic. It's giving me goosebumps right now, and I just want to say thank you from the bottom of my heart, and not just for this campaign, but all that you're doing for the science community. You are putting so much effort into. Bear in mind how hard you work in your research. Just to consistently be on social media. And bear in mind, guys, I'm always on social media, but I have a team. Like, I'm not just me alone. I have 6 people working in my company to make sure that I can do what I do. Sophia is doing this single-handedly. She is literally a superwoman. So thank you, Sophia. And thank you, Diana, for having us on too.
Yeah, thanks for being on. And I agree with everything you said. Sophia is an amazing person. And Kat, so are you. 2 amazing people up here on screen with me. Really, really happy you could both join me today. Sophia, any closing thoughts from you, or are you a bit overwhelmed?
Yes, I'm like I was almost brought to tears. Thank you so much for all your kind words, and I want you to know, Catherine, that I'm also very thankful to be able to do this with you. You're incredible at what you do. You're a wonderful person, and I just I know we've met once in real life, but I want to meet with you again, and I just want to keep working with you. You're just amazing and brilliant at this, and thank you so much. And Diana, thank you so much for having us here. Brilliant physicist. Okay. And thank you all for coming. I'm a little bit at a loss for words, because I didn't expect all that, and I appreciate that so much.
I would also like to thank Waterproof Mascara right now.
Good thing, good thing. So reminder everybody, this collaboration goes live on the 10th of June. You can find the link to follow, get an email when it goes live. Be sure to buy the artwork, support this collaboration, show them that you want to see more of this in the future, and get some cool space art for your home. I put the link again in the comments. Make sure you all follow this. Sophia, Kat, thank you so much for joining me up on screen. It's been amazing to have you. As I said, you're both welcome back anytime on the platform. I'm going to take you off of screen now, but please do stay online.
See you guys.
Okay, that was an amazing broadcast. I'm so happy that Kat and Sophia joined me here today. I had my fangirling moment as well. I respect these two women so much, and I have some of Kat's art. It was amazing for me as well to have them on my show. So to everybody who's joined along in the comments from whichever platform you were watching us on, thank you for joining. If you were elsewhere from Happs, please do come over to Happs. This is where all the fun is. This is where you can see all of the comments properly, and it's where you can give awards. To everybody who's given us awards today, thank you so much. We really do appreciate the awards. For anybody who doesn't yet know or doesn't follow me regularly, any awards I get on this channel, I do put back into organizations promoting better accessibility in STEM, in science fields in general, be it helping young girls come into science or people from underrepresented backgrounds. So any awards you give me do go back into the system. So thank you everybody for this. It's been great. I've done a lot of broadcasts this week, but I will be back online on Sunday for my regularly scheduled broadcast. That's 5:30 p.m. Central European Summertime. Not yet sure on the topic. Will probably just be a general ask me anything about the universe. I hope to see you then. And if you haven't had enough of science collaboration, you should all head over to Georgia's broadcast now, where they're doing the science collaboration part 2, follow on from our Wednesday broadcast. So I'm doing a Happs pass to Georgia. Make sure you all head over to Georgia's channel now. I hope I will see you, getting tongue-tied. I hope I will see you all again on Sunday. Thank you everybody for being here. I hope in the meantime, you all stay safe and take care of each other.